This video is a summary of the paper relating to the environment through photography, the smartphone camera as a tool in urban farming. OzCHI research is investigating how technology can support more sustainable lifestyles. Photography is one way to do this. It is literally a lens directed at the environment. The smartphone camera can be used to quickly and quite fluently depict, save, share, and even access, augment, or amplify information about the environment. Recent technological advancements of smartphone cameras, image processing, and image recognition spurs new practical applications of using the smartphone camera to understand and act in the environment. We primarily focus on the taking of pictures to meet a certain practical purpose, such as organizing cultivation or recognizing species. These photos are not necessarily Instagram friendly and taken with the purpose to be aesthetically pleasing, act as memorabilia, or for social signaling. Instead, we view them as materials that can be shaped and processed by tools, or even as tools themselves. The paper is based on data collected during 2 years of participant observation studies in an urban community farm in Stockholm, Sweden. This site was chosen since the urban farmers can be seen as particularly engaged citizens that experiment on how to live more closely to the environment and as early adapters of more sustainable behaviors and uses of technology. We complemented the observations with a survey focused on the use of the smartphone camera. The aim of our research is to provide empirical grounding on how the smartphone camera is used as a tool in urban farming. We ask what types of photography occurs, how are users experiencing different types of photography, what triggers using the camera, how are interfaces designed around photography. We further aim to discuss if and how technological mediation of the environment may strengthen practices that are more environmentally sustainable. We show examples of using the smartphone camera for remembering the location of actions and objects, tracking changes in physical sketches, measuring distance, taking pictures through analog microscopes, recognizing unidentified species through asking questions on social media, and through applications based on artificial intelligence. For more detailed analysis of each example, we refer to the paper. A more general finding was that the urban farmers adopted simple utilizations of the smartphone camera centered around the action of taking a photo and only a few more interactions. The function of compiling the date, location, and image in one interaction was especially appreciated. In contrast, more complex virtual interfaces, in terms of, for example, the number of interactions needed to perform a task, were not adopted in the urban farm. We particularly highlight use of the smartphone camera from a sustainability perspective. We found that the smartphone camera was used to activate analog devices and physical materials, thus supporting reuse and repurposing, and to deepen the experience of the natural environment. For example, the urban farmers drew maps of the cultivation on paper taped on plywood boards to facilitate the collaborative planning, planting, and caring of crops. Taking pictures of these boards enabled keeping track of changes and having a virtual backup if something would happen to the physical sketch. This activation enables smart functionality such as digital saving, sharing, and editing. The act of photography further supported both creation and sharing of knowledge, and feelings of closeness and bonds with the local environment. This enabled the urban farmers to respond more appropriately to actual needs in the environment. To conclude, we studied the use of the smartphone camera as a tool for relating to, acting in, and remembering information about the local environment. We emphasize that it's crucial to understand how technologies shape relations to the environment in order to design more sustainable technologies.